All right, so in class we're going to be starting to talk about how to write chemical formulas for ionic compounds. This PowerPoint is set up to review some basics about chemical compounds and to teach you about the crossover rule, which is the approach that we're going to use to write formulas for ionic compounds. You might want to have a periodic table handy, as well as the polyatomic ions that you were assigned to memorize, just in case you don't have those committed to memory. Okay, so when we're writing formulas for compounds, you're going to be writing chemical formulas for ionic compounds. And remember that a compound that is ionic forms from two unlike charged ions. And an ion is a group of atoms or an atom that has either a positive or negative charge. And it has a positive or negative charge because it has gained or lost electrons. Okay. Now there's two different types of ions. There's what are called cations. So even though it looks like one word put together, you do pronounce them each separately. A cation is an atom or a group of atoms that has a positive charge. Metals usually form cations. The other type of ion is called an anion, and again, you pronounce each part separately. And anions are atoms or groups of atoms that have a net negative charge, and these are generally formed by nonmetals if we're talking about single elements. Now, cations and anions, because they are unlike charged, are going to be attracted to each other, and when they come together, they're going to form a compound. To review, chemical compounds are substances that contain two or more elements that are combined in a fixed proportion. So fixed proportion means like 1 to 1 or 1 to 2. So they're held together in a consistent ratio. And remember that compounds are held together with either an ionic bond or a covalent bond. And we're focusing primarily in this PowerPoint, we're focusing on writing formulas for ionic compounds. Now, so cations will either be a metal or the polyatomic ion ammonium. Anions are either going to be nonmetals or one of the other various polyatomic ions. So let's look at what might happen if you combine a cation with a cation. You're not going to get a compound. Why? Because two cations, positive charge combining with a positive charge, like charges repel. If you have two anions, you will get a compound, but it's not ionic. Okay, so to review here, and this is something that I want to, before we move on to the next slide, for an ionic compound, you need a positive ion and a negative ion, and those will make an ionic bond because unlikes attract. Okay, so we're going to look at some examples of ionic compounds, and I could come up with a fair number. Well, here's one: Ki, BaO, BeCl2, NaCl. These are all ionic compounds. This is potassium iodide. This is barium oxide. This is beryllium chloride. This is sodium chloride. And let's toss another example in here. How about NH4OH? Notice that there's two polyatomic ions in this compound. This is ammonium hydroxide. Okay. So we're going to learn in class more about how to come up with these names, but I want you to have some background in writing formulas before we come up with the names. All right, so you might be asking yourself, how exactly do you write a chemical formula? How do you know this? Well, you're going to look up the charges of the elements involved on the periodic table. So the periodic table I gave you in class does have ionic charges listed next to each symbol, and you'll see that for some of them there's a variety of charges, but at least one that's in boldface, and the boldface is the most common one for that element. So you're either going to use your periodic table or you're going to remember the formula and the ionic charge of the polyatomic ion that I asked you to commit to memory. So once you have that information, you're going to use this rule called the crossover rule. And this rule says that the charge on the cation becomes the subscript on the anion and vice versa. The charge on the anion becomes the subscript on the cation. The key is that they lose their signs in that process. So in other words, the charges switch which element they're paired with, they lose their sign and they drop down to become subscripts. So there's some things we need to keep in mind. First of all, compounds always have a specific order that they're written. So they're written cation, anion. So in other words, the positively charged ion followed by the negatively charged ion, or metal then nonmetal in some cases. Compounds themselves are neutral. They don't have a charge. So that means that the charges have to balance out to add up to a total of 0. So when they switch their pairing, they do lose their sign though. So for example, and we'll go with one of the ones that I listed on the previous page. So I want to know what's the chemical formula going to be when I combine potassium, which is K, and iodine, which is I. So first step is I'm going to look on the periodic table and I'm going to find the ionic charge for potassium. And when I find potassium, I see that it's in group 1, so it makes an ion with a +1 charge. I'm going to do the same thing for iodine. Iodine is in group 17, and next to it you should find a -1. So there's the ionic charges. So I've done step 1. Now I'm going to apply this crossover rule. What the crossover rule says is that this +1 crosses over and becomes iodine subscript. This -1 crosses over and becomes potassium subscript, but they both drop their sign. So what this becomes is K1, I1. And usually the convention is to just write that Ki. We're going to do a whole bunch more examples on the next page, so you're going to see more about this. But again, we've accomplished all of 3 bullets. Okay, so the first step here, and I'm going to do it for each one of the elements or ions, is to fill in their charges. So I'm going to use my periodic table as a resource. So strontium's in group 2, it's a +2. Chlorine is in group 17, it's -1. Magnesium is also group 2, so it's +2. Sulfur is in group 16. You might see more than one charge written next to sulfur, but you're looking for the -1. Aluminum is in group 13, it's +3. Sulfate is -2. Potassium is in group 1, it's +1. Oxygen is in group 16. It might have multiple charges, but again, you're looking for the -1. Calcium is in group 2. Phosphorus is in group 15, and again has multiple charges, but you're looking for the -1. Strontium is +2 because it's in group 2. Nitrate is -1. Ammonium is +1. Sulfur is -2. Calcium is in group 2, so it's +2. Carbonate is -2. Ammonium is +1. Phosphate is -3. Okay, so the next thing that we're going to do is we're going to apply the crossover rule. So for example, this one, Sr +2, Cl -1. So the crossover rule says this -1 comes over here and becomes strontium's subscript and loses its sign. This +2 comes over here, becomes chlorine subscript and loses its sign. So the chemical formula is Sr1Cl2, or we generally would write that SrCl2. The next compound here, the Mg and the S. So Mg +2, S -2. Okay. Applying the crossover rule, that rule says the -2 comes over here, becomes magnesium subscript, so it loses its -2. The +2 comes over here, becomes sulfur subscript, loses its sign. So Mg2S2. And what you should see is that those will reduce to just MgS. The next one here, the Al and the SO4, so it's Al plus 3, SO4 minus 2. Okay. Key here is that you can't touch what's inside the parentheses, so because that's the formula for sulfate. So the minus 2 comes over here, drops its sign, becomes aluminum subscript. The plus 3 comes over here and lands on the outside of the parentheses. So the chemical formula here is Al2 SO4 inside the parentheses, 3. Okay. Next one, K plus 1, O minus 2. Minus 2 comes over here, loses its sign, and the 2 becomes potassium subscript. The plus 1 comes over here, drops its sign, and becomes oxygen subscript, so K2O1, or we just would write that K2O. Okay. The next one, Ca plus 2, P minus 3. The minus 3 comes over here, drops its sign, and the 3 becomes calcium subscript. The 2 comes over and becomes phosphorus subscript, and it loses its sign. So this chemical formula is Ca3P2. Okay. Next one, Sr plus 2, NO3 minus 1. Same deal, we can't touch what's inside the parentheses. Okay, the minus 1 comes over here and becomes strontium's subscript, loses its sign. Plus 2 comes over here and lands on the outside of the parentheses and becomes nitrate subscript. So Sr1 NO3 2, and again we would just write that SrNO3 2. Okay. The next one, NH4 plus 1. S minus 2. Okay. Minus 2 comes over here, drops its sign, and becomes ammonium's subscript, so it lands on the outside of the parentheses. The plus 1 comes over here. 1 becomes sulfur subscript, and it doesn't have a sign. So the chemical formula here is NH4 2S. The next one, CaCO3, Ca plus 2, CO3 minus 2. The 2 comes over here, drops the negative sign. 2 comes over here, drops the positive sign. So it's CaCO3, okay? Because that's simplified from Ca2 CO3 2. So that's the right answer right there. And last but not least, NH4 plus 1, PO4 minus 3. Okay, so this one's got 2 polyatomics. So again, remember you can't touch what's inside the parentheses. The 3 comes over here, drops its sign, and becomes ammonium subscript. The 1 comes over here, drops its sign, and becomes the phosphate subscript. So the chemical formula here is NH4 3 PO4. So tomorrow, or the next time you have class, we will start with a do now, where we're going to be doing several of these. So it will be helpful if you have these notes completed, because you'll be able to use them as a resource.